Part C. Integration by partial fractions. When we have a rational function p of x over q of x, and the degree of the numerator is less than the degree of the denominator, we can decompose it into simpler fractions. Each simple fraction like a over x minus a can be integrated directly using the natural logarithm. The integral of 1 over x minus a is ln of the absolute value of x minus a plus c. For repeated factors, 1 over x minus a squared integrates to negative 1 over x minus a plus c. And for irreducible quadratics, we get inverse tangent terms. There are 4 main types of partial fraction decomposition. Type 1. Distinct linear factors. For example, if the denominator is x minus a times x minus b, we write a over x minus a plus b over x minus b. Type 2. Repeated linear factors. If we have x minus a squared in the denominator, we need both a over x minus a and b over x minus a squared. Type 3. An irreducible quadratic factor like x squared plus b gives bx plus c over x squared plus b. Type 4. Repeated quadratic factors need similar treatment. In G, types 1 and 2 are the most frequently tested. Example 1. Find the integral of 1 over x minus 1 times x plus 2 dx. We decompose into a over x minus 1 plus b over x plus 2. Multiplying both sides by the denominator, 1 equals a times x plus 2 plus b times x minus 1. Putting x equals 1 1 equals 3a, so a equals 1/3. Putting x equals negative 2 1 equals negative 3b, so b equals negative 1/3. Now we integrate each simple fraction, 1/3 ln of x minus 1 minus 1/3 ln of x plus 2 plus c using log properties. This is 1/3 ln of the absolute value of x minus 1 over x plus 2 plus c. Example 2. Integrate to x plus 3 over x plus 1 times x squared plus 1. Since x squared plus 1 is an irreducible quadratic, we decompose as a over x plus 1 plus bx plus c over x squared plus 1. Putting x equals negative 1 1 equals to a, so a equals 1/2. Comparing coefficients of x squared gives b equals negative 1/2. Comparing constant terms gives c equals 5/2. Integrating each term, 1/2 ln of x plus 1, minus 1/4 ln of x squared plus 1, plus 5/2 are 10x, plus c. Notice the graph has a vertical asymptote at x equals negative 1. When should you use each method? If you see a composite function with its derivative present, use substitution. If the integrand is a product of two different function types, like algebraic times trigonometric or algebraic times exponential, use integration by parts with the eyelet rule. If the integrand is a rational function, a polynomial divided by another polynomial, use partial fractions. Sometimes you may need to combine methods, for example, partial fractions followed by substitution for each term.